Hello everyone, let's see this question. Horizontal wax bar B rests between a wedge and a vertical wall as shown in the figure. The wedge starts moving towards the wall with a constant acceleration of this much. The moment the wedge starts moving, continuous supply of heat is there from the wall which melts the bar. Okay, and the bar always remains horizontal. Then which of the following conclusions can you make? So let's see what is going to happen here. Let's try to understand that. Okay, so we are going to make the bar like a point because no information is mentioned regarding its thickness, so we are going to assume like a point only. Now let's say the bar initially is here. Okay, the bar is initially here, and now after some time the plane moves forward. Okay, the plane moves forward. Now if the bar would have melted this much, then it would have remained stationary. But if it melts less, then it is going to climb up, right? Because it has melted less, it is going to climb up. So let's say this distance is AB and this is CD. So if the bar would have melted by AB, it would have remained here. But since this extra length is there, CD, that's why it goes up. Now, how do we calculate this length? So the AB is the distance that the inclined plane has moved, and AC is the length by which the bar has melted. So we can say that CD, let's call here C dash. So we can say that CD is equal to C dash B, which is nothing but AB minus AC dash. Now how much is AB? It is the distance moved by the inclined plane. Okay, so it is given that inclined plane is moving with constant acceleration. So AB will be half AT square, and bar is melting with a constant speed, let's say Vm. So Vm into T, by this much the bar melts. Now by how much it has gone up? So this CD length we have with us right now, and the angle also we know, let's call it theta. So this is also theta. So the length by which it has gone up, SY, let's call it SY, will be how much? It will be CD into tan theta, right? And it's 37 degree, so tan theta is 3 by 4. So what do you get? You get AT square by 2 minus Vm into T into 3 by 4. This is the displacement along y. And let's now take this expression and let's just see the options with which this expression, whether it agrees or not. So first option is the bar moves downwards and then upwards. So in this case we'll have to find out the velocity of the bar. So Sy is given. So Vy will be what? It will be AT minus Vm into 3 by 4. So initially what will happen? AT is lesser than Vm because T is nearly 0. So initially velocity is downward, right? And then after some time, what is going to happen? After some time, AT will become greater than Vm. At some point, it will also become equal to Vm. So the bar will first go down, Sy is negative first, then it becomes 0, and then it will be positive. So Sy is actually displacement, so it will be 0 when it comes back here. Okay, the position will be negative first, and then it will begin to increase. Okay, so is the first option correct? Bar moves downwards and then upwards. Yeah, that's correct. Then bar stops for a moment after t equal to 2 seconds from the beginning. So at t equal to what time will it stop? We can find out very easily from here. We just have to equate this to 0. So when we equate this to 0, what do we get? We get t is equal to Vm by A. Okay, so Vm is 1 and A is 0.5 in same units. so you get 2 seconds. Okay, so this second option is also correct. Now in C and D, I think this has been corrected in the new edition of the book, but the PDF that I have, in that it is written 1.2, it should be 1.5. Using that only we get the answer. So modulus of displacement of the bar in the first 4 seconds is this much. So you can just keep uh, the value of t here as 4 and check that. So if you keep the value of t as 4 here, then what do we get? Let's see. So we get a into a is how much? A is 0.5. 0.5 into 4 square by 2 minus 0.1 into 4 into 3 by 4, right? So how much this comes out to be? This comes out to be Vm into t, 0.5 millimeter per second, and this is 1, not 0.1, this is 1. So what does it come out to be? It comes out to be 0. So at t equal to 4 second, it is back where it started from. So as I told you, it goes down and then comes back. Now in the previous situation, we already know till what point it goes down. So it goes down, t equal to 0, it starts going down. Till t equal to 2 second, it is going down only. And then after that, it returns back. So that means what? Whatever is the distance covered from 0 to 2, same distance will be covered from 2 to 4. So how much is that distance? You can easily get that by substituting 2 in the equation. If you substitute 2, so you'll get what? 0.5 into 2 square by 2 minus 1 into 2 into 3 by 4. So how much do we get? We get 2 is cancelled with this 1 minus 1 into 3 by 4, which is minus 0.75. Minus we are getting because it is going down. So 0.75 it goes down and 0.75 it goes up. So displacement is not 1.5, but distance is 1.5. So that's the answer.